Okay, I want to continue our conversation about the classification of matter and how scientists love to classify things, and they'll often have multiple systems so that they can categorize things into different ways, which allows them to explore different aspects of whatever it is they're classifying. And so matter is no different. We can classify matter based on physical and chemical properties. We can also classify matter based on composition. And that leads us to another system that looks like, let's start this concept map off. So we have matter. Any form of matter can be classified as one of the following: a pure substance or a mixture, and that's based on composition. Is it a constant composition or a variable composition? Other ways that we can say that: a pure substance is a substance with uniform composition. A mixture has variable composition or is a combination of substances not chemically combined. I find these descriptions a little bit difficult or maybe misleading, and let me illustrate. So right here, I have two different samples of matter, and one is a pure substance and one is a mixture. And it's not necessarily obvious. They both, especially if I kind of like wiggle them around, they both seem to have a really uniform composition to me. And so I've always found that confusing. They both look like they have a uniform in composition. So what do we really mean? So I like to kind of add at the particle level. Well, we're talking about if we could zoom in and see the particles, a uniform composition at the particle level. Or another way to say that is a pure substance is made of one kind of particle. A mixture is going to be made of multiple kinds of particles. And I want to use that word particle very loosely here, just very generically, just the particles that make it up. So let's start then with our mixture, which happens to be this one. So this is just a solution of salt water. So it's a mixture of different substances. It appears to have uniform composition to me, but if I could zoom in and look at it, again, at that particle level, I might see something like this. And from this level, I can actually see I have multiple kinds of particles. I have this like large particle here representing my water, and then I also have these other particles there that even have a charge. So these substances, these different particles, aren't chemically joined together. They're just mixed together, and each then is retaining its own set of chemical and physical properties. If I were to taste that, I'd be able to taste the salt. It's not really a new substance. It's a mixture of these other substances, and therefore a mixture of those properties. In fact, it wouldn't really be very hard to separate these particles out because they're not chemically joined. All I'd really have to do if I wanted to would be to boil off the water and collect it in a separate container, and what would be left then in my test tube would be the table salt. So then I'd have them separately. So here are some maybe common examples of mixtures. You have a lot of mixtures in your life. So a cup of coffee, milk, blood, and they're all mixtures because at the particle level, there's more than one kind of particle. There's more than one kind of substance, and they're just physically joined together. Now, chemists like to sometimes further categorize mixtures based on how uniformly they're mixed. That's where the homogeneous and heterogeneous come in, and those can be further classified as well, and you hear words like colloid and suspension, things like that. So then, going to our pure substance, which was this one, which was just water. And we can talk about this substance, or if I had taken my mixture and separated out into just the water, if I zoom in there, I see uniform composition. Every particle here, and really the correct word for this one would be molecule, every particle is identical. So it's not just this mixture of lots of different particles, every one is identical. However, you can see from water that this particle, this larger particle, is made up of different things put together. And we've learned that I can't physically separate this white sphere from the red sphere. I can't get them apart physically. But if I were to run an electrical current through this sample, I would be able to generate and collect two different gases. So two new things. And at the particle level, they'd look like this. So I have here this double sphered particle representing oxygen gas, and this white sphere double particle here representing our hydrogen gas. And you can see that in each of these samples, we have one kind of particle, one kind of particle. So through a chemical change, I was able to take one pure substance and generate two entirely other pure substances. This really illustrates the further classification that we can do of pure substances. Pure substances can be categorized as either an element or a compound. And the same with just talking about matter, and you can't necessarily tell a pure substance from a mixture just by looking at it. Sometimes you can. If you can see distinct separate pieces, it's safe to assume it's a mixture. Elements and compounds end up being kind of the same here. I have these two samples here. Let me hold them up there. These two samples here. This looks like a little white rock. This looks like kind of a maybe a silver metallic looking rock. One of these is an element and one of these is a compound. Again, I don't think there's anything about their properties just looking at them to give you that, to answer that, which is which. So again, we're talking about it at the particle level. We're talking about what the particle itself is composed of. So elements are the simplest type of matter that can't be decomposed into other forms. So water can be decomposed through a chemical change into hydrogen and oxygen gas, but you can't take hydrogen and oxygen gas and chemically decompose them further. It's kind of the bottom of the end of the line in terms of the simplest type or form of matter. And we've identified over 100 different such kinds, and they're all located on the periodic table. So all of those on the periodic table represent the simplest form of matter, where every particle that we'd be looking at that particle level view would be of the same kind. So this happens to be a sample of zinc. And so zinc is on the periodic table. So if I could zoom in to that atomic level, I would see all these identical little particles of zinc atoms. So I can't decompose an element, but I can chemically react them together. And that's what compounds are. Compounds are a type of matter composed of two or more elements chemically combined. So they're not just mixed together like making salt water. They're chemically reacted together. And therefore they could be decomposed. So this sample here, this was calcium carbonate. And you can even hear in its name that it's a compound because it has two element words there. We have calcium and then something else. So we know that there's more than one element there. So you can see that we have a really distinct relationship here between elements and compounds. Elements can be chemically reacted together to make compounds. And when they do so, they do it in a very fixed ratio. So that's where like the H2O comes from in the chemical formula. We're saying that two atoms of hydrogen react with one of oxygen, and we get our H2O in that fixed ratio. And then compounds can be chemically decomposed into elements. And something that's really important to understand here is each time we do this, we're generating a new pure substance. We don't have a mix of properties. We have a completely new pure substance with completely new properties. A really classic example of this is table salt. Table salt is sodium chloride, so it's made of the elements sodium and chlorine reacted together. Well, sodium is explosive, reacts explosively with water, and chlorine is a poisonous gas. But together, when they've chemically reacted to make this new pure substance, clearly your steak doesn't explode if you put some salt on it. So we have completely new properties. So then to kind of summarize all of this, looking at all of it together, so we have all matter can be classified as a pure substance or a mixture. We have a relationship between pure substances and mixtures. We can create a mixture by physically mixing pure substances together, and we can use physical means to separate that mixture back into the component parts. Mixtures can be classified by how uniformly mixed they are, being very uniformly mixed, same and then different. And then a pure substance we classify based on, is it an element or a compound? Is it the simplest kind of matter and then we're going to locate it on the periodic table? Or is it multiple ones of those reacted together to make a compound? So remember to refer back to your learning outcomes page to kind of assess how well you feel like you're meeting those objectives that are laid out there. And as always, if you ever have any questions, let me know. I will see you guys soon.